Le Chatelier's principle. According to Le Chatelier, when a chemical system is disturbed, it reattains equilibrium by undergoing a net reaction that reduces the effect of disturbance. Three common disturbances are change in concentration, change in pressure caused by change in volume, and change in temperature. Changes in concentration. Changing the concentration of any of the reactants or products will cause the equilibrium position shift to the direction that will reduce the effect of disturbance in order to achieve a new equilibrium. When the concentration of reactants being increased, the equilibrium position will shift forward, mean from left to the right, from reactant to the product, in order to reduce the effect of the added reactant by forming more products until a new equilibrium is reached. The value of K at this temperature remains the same, as long as the temperature does not change, the value of K remains unchanged. Equilibrium shift. For example, PCl3 reacts with Cl2. The product is PCl5. This is a chemical reaction. When you add more Cl2, means you add more reactant. The disturbance is addition of Cl2, means the concentration of Cl2 increases. When the concentration of Cl2 increases, means the concentration of reactant increases. You have more reactant, means the value of QC is less than the value of KC. System will reduce the disturbance by reducing the concentration of Cl2 because you have added more Cl2. Now the system must reduce the concentration of Cl2 to make this balance again. In order to reduce the concentration of Cl2, the equilibrium position shifts to the right until the value of QC is equal to Kc. In order to do that, this equilibrium position shift, the chemical reaction, must consume some additional Cl2, means it has to reduce the Cl2 by increasing the PCl5. When Cl2 is reduced, the Cl2 must react with PCl3 in order to produce PCl5. So to decrease the concentration of Cl2, the concentration of PCl3 will also decrease because this Cl2 concentration will react with PCl3. So if you want to decrease this concentration, the concentration of PCl3 is also decreased because it will react with Cl2. When these two react, it will produce PCl5, so the concentration of PCl5 increases. When you remove the PCl3, means the concentration of PCl3 decreases. PCl3 is a reactant. When you remove the PCl3, means you have more product than the reactant. The value of QC is more than Kc. When you have less reactant, more product, system will reduce the disturbance by increase the PCl3 because you remove initially, so the system will balance again by increasing the concentration of PCl3 again. If we want to increase the concentration of PCl3, the product must be converted to be the reactant. PCl5 must be converted to become Cl2 and PCl3. Equilibrium position shift to the left because the product is convert itself to become PCl3 until QC is equal to Kc. This means the PCl3 increases, Cl2 increases because the product converts itself to become the reactants, these two reactants, and the concentration of the product will decrease. Example, to improve air quality and obtain a useful product, sulfur is often removed from coal and natural gas by treating the fuel contaminant hydrogen sulfide with oxygen. This is a chemical equation. Hydrogen sulfide reacts with oxygen to produce sulfur and water vapor. What happened to the concentration of water if oxygen is added. You add oxygen, what happened to the concentration of water? When oxygen is added, the concentration of oxygen increases. So this is the disturbance. When you add oxygen, concentration of oxygen increases. To reduce this disturbance, you need to remove the oxygen because you have more oxygen, because you add oxygen. So to make it balance again, you need to remove the oxygen. So reduce the disturbance by reducing the concentration of oxygen. In order to reduce the concentration of oxygen, you need to convert the reactant to become the product. So this oxygen must be reacted with hydrogen sulfide to become the product. So equilibrium position will shift to the right. When equilibrium position shifts to the right, it will produce more water vapor, means the concentration of water vapor increases. Next, if oxygen is added, what happened to hydrogen sulfide? So you add oxygen, means oxygen concentration increases. The disturbance is you have more oxygen. In order to make it balance again, you need to remove oxygen again. So you need to decrease the concentration of oxygen, reducing oxygen concentration. In order to reduce the concentration of oxygen, you need to react this oxygen, need to react with hydrogen sulfide to produce the products. So the concentration of hydrogen sulfide will decrease. What happened to the concentration of oxygen if hydrogen sulfide is removed? When you remove oxygen sulfide, means the disturbance, the concentration of hydrogen sulfide decreases. So when the concentration of hydrogen sulfide decreases, you want to make it balanced by adding more hydrogen sulfide again. So to reduce the disturbance is increasing the concentration of hydrogen sulfide. In order to increase this concentration, you need to convert the product to become the reactant. So equilibrium position will shift to the left. So when the product is converted to become the reactant's concentration will increase, so the concentration of oxygen will also increase. Next, what happened to hydrogen sulfide if sulfur is added? Note that sulfur is solid product. No disturbance because sulfur is solid, has no effect on equilibrium. So when it has no effect on equilibrium, the concentration of hydrogen sulfide reactant remain unchanged. Changes in pressure. Significant only for system involving gaseous components because it's pressure, so we only take account gaseous components. Pressure of an equilibrium system can be changed by changing the volume of reaction vessel. When you have large volume of the vessel, we're not talking about gas, we're talking about the vessel. Large volume of the vessel means a large volume of the gas, so lower pressure. Because when you have large container, fewer collisions per unit volume. That's why you have low pressure. In a small volume or small container, more collisions per unit volume can occur. So more collisions means higher pressure. So this is the differences between large volume container and small volume container. It produces different pressure. Case number 1. Changes in volume. The disturbance is volume of the system is decreased. When the volume of the system is decreased, the gas pressure will increase. The gas pressure increase, the system is not at equilibrium anymore, means the value of QC is not equal to KC. The system will reduce the disturbance by reducing the number of gas molecules in order to reduce the gas pressure. So you need to lower the gas molecules, number of mole of gas molecule, to lower the gas pressure because the disturbance is gas pressure increase. In order to make it balance again, lower the pressure. by reducing the number of mole of the gas. Equilibrium position will shift to the right or side with fewest number of mole. If you look at the reactant, the total number of mole of the gas is 2 mole. 1 mole for PCl3, 1 mole for Cl2. 2 mole of gas at the reactant and 1 mole of gas at the product. So in order to reduce the gas pressure, you need to shift the equilibrium position to the side with less number of mole, because less number of mole will produce less pressure. So from higher number of mole to lower number of mole until a new equilibrium is achieved. So when the equilibrium position shifts to the right, the PCl3 and Cl2 concentration decrease and PCl5 concentration increases. Case number 2, the disturbance is volume of the system is increased. If you increase the volume of the system, means less collision between the gas particles, so gas pressure immediately decreases. The value of QC is not equal to KC, means it is not at equilibrium because there is disturbance. So when you have less gas pressure, less collision because you increase the volume, now you need to increase the gas pressure back because the disturbance is lower gas pressure. So you need to increase back the gas pressure and decrease back the volume of the system. So in order to increase the gas pressure, you need more number of mole per unit volume. So the equilibrium shift will proceed to the left. System will reduce the disturbance by increase the number of gas molecules in order to increase the gas pressure. Equilibrium position shift to the left side with more number of mole until a new equilibrium is achieved. When the equilibrium position shifts to the left, the product concentration will decrease and the reactants concentration will increase. Changes in volume and pressure. If you increase the pressure, means decrease the volume, the shift of the equilibrium will side to the fewest number of mole of the gas. Increased pressure, more collision between particles. More collision between particles means you need to balance it again, so the shift will be to the fewest or least number of mole of the gas. That same goes to the volume decrease. Next, if you decrease the pressure, means you increase the volume. Decrease pressure, increase volume, volume of the system. Decrease pressure, increase volume means less collision between particles. Less collision between particles, so you need to balance it again. You need the collision, more collision. So you need to increase the number of mole. Increase the number of mole, so shift the equilibrium side with the most mole of the gas or higher number of mole of the gas. Example, 2SO2 gas reacts with oxygen gas to produce 2SO3 gas. At original equilibrium, you have a volume of a system 10 liter given the number of mole of each compound. And then when the volume decrease, the volume of the system is decreased, means the gas pressure increase. When the gas pressure increase, the equilibrium shift must be to the less number of mole. Increase gas pressure by decreasing the volume, so gas pressure increase. When the gas pressure increase means more collision. More collision, the shift must be to the less number of mole. So at the reactant, you have 3 moles. At the product, 2 moles. So the shift equilibrium to the right. So the concentration of SO3 will increase. So if you look, the number of mole of SO3 increase, but the number of mole of SO2 and the number of mole of O2 decrease because the equilibrium shift to the right from more number of mole to less number of mole when the gas pressure increase. Addition of inert gas at constant volume, fixed volume of the system. When you keep the system volume fixed, this happens when you add the inert gas into the system. Adding an inert gas will increase the pressure because you have more collision. Increase the pressure, thus increasing number of collisions. But since it is inert, means it doesn't react with any particle. This inert gas doesn't react with any particle. It just collides. It will not cause any reaction, leaving the equilibrium intact. Means even though you add gas in the system, the inert gas you add in the system, but there will be no effect on the equilibrium position because this gas is inert. It doesn't react with any compound in the system. So no effect on the volume, no effect on the partial pressure. Partial pressure means the pressure of each compound of the system. But the total gas pressure increase because you have more molecules. You have inert gas, you have the compound in the system, so the total gas pressure increase, but partial pressure of the compound in the system remain constant. All reactant and product concentration remain the same because inert gas doesn't react with any compound in the system. Only total gas pressure increase. Other than that, remain unchanged. For example, you have 2 mole of reactant A to produce 1 mole of product B. This is at constant pressure. Previously, this one at constant volume. The volume is fixed. This one, the pressure is fixed. You need to fix the pressure when you add the inert gas. Before, you have volume of the system 1 liter, and then you add helium, for example, inert gas helium, add into the 1 liter of system, consists of A and B, A reactant and B product. So the pressure total equal to partial pressure A plus partial pressure B. This is before you add the inert gas. This is the pressure total. For example, 20 atm. Each partial pressure 10 atm, A 10 atm, B 10 atm. So the pressure total 20 atm. At constant pressure, you need to keep this pressure total fixed, 20 atm. After you add the inert gas, you need to keep it fixed. So pressure total after, you need to keep it 20 atm. The volume, you must increase the volume because you want to fix the pressure. You have more molecules in here because you add inert gas. Now you have A, B and helium. So you have more molecules. When you have more molecules, you want to make the pressure fixed. You need to increase the volume. And then, when you want to make the pressure total fixed, this partial pressure will decrease. Initially 10 plus 10, 20. So A plus B plus HE must equal to 20. The effect is partial pressure of A, partial pressure of B must be less than 10 because you need to add the helium pressure as well. How to overcome this? Increase pressure by produce more moles. So in order to overcome this, you need to increase the pressure by produce more number of moles. So in order to increase the pressure by produce more number of mole, you need to look at this equation. In order to produce more mole, the equilibrium must shift to the left. 1 mole B, 2 mole A. So equilibrium will shift to the left. So if equilibrium shifts to the left, you will have more number of mole on the left. This is how you increase the pressure. Increase in volume, partial pressure of each gas decrease. Equilibrium shift to the side with more moles of gas to increase the pressure. This is what I explained here. Equilibrium shift to the side with more moles of gas to increase the pressure. When inert gas is added, total number of moles will increase. The total pressure should increase as well. But since the total pressure is kept constant, you cannot increase the total pressure because at constant pressure, you have to keep constant. You must to increase the volume of the container or the volume of the system. So if you increase the volume of the system, partial pressure of each gas will decrease. When you increase the volume, partial pressure of each gas will decrease. And then the equilibrium position shift to the side with more of gas, because when you increase the volume, partial pressure decrease. When you decrease the partial pressure, you need to balance back again to increase the pressure again. So you need to, when you need to increase the pressure again, you need more number of moles. If you need more number of moles, the equilibrium position shift to the side with more moles of gas to increase the pressure. So here you have 2 more A, 1 more B, more number of mole, equilibrium shift to the left. Next, changes in temperature. When the temperature of the system is increased, endothermic reaction is favorable as to reduce the temperature of the system by absorbing the added heat. Means, increase the temperature, endothermic reaction is favorable. Endothermic reaction means it absorbs heat. Endo means absorb heat. So if the temperature increase, you need to absorb heat in order to make that balance again. When the temperature of the system is decreased, means the temperature lower the temperature, it's cooling down, exothermic reaction is favorable. Exo means release heat into the system. You release heat to the system. So when the temperature is decreased, exothermic reaction is favorable to make it equilibrium again. Only temperature change can alter K value. Only temperature change can alter equilibrium constant value. The effect of temperature on an equilibrium depends on the type of the reaction, whether it is delta H positive kilojoule or delta H negative kilojoule. If you look at that chemical equation and the delta H given is positive, if the delta H given is positive, means the forward reaction is endo, reverse is opposite. If the delta H given is negative value, the forward reaction must be exo and the reverse is the opposite. For example, here you have N2O4, reactant becomes 2NO2 product. Given delta H is positive 57 kilojoule. When delta H positive, the forward reaction, the arrow on top, must be endo. And for this one, delta H negative, the forward reaction must be exo. Positive indicates that heat is absorbed for forward reaction. And the negative sign indicates energy is given off, or negative means heat is released for forward reaction. Increasing the temperature of the system. For example, given this chemical reaction, N2O4 as the reactant, 2NO2 as the product, given delta H is positive. When delta H is positive, means the top arrow or the forward reaction is endo, means it absorbs heat. When the temperature of the system is increased, this is the disturbance. You increase the temperature of the system, disturbance, increased temperature of the system, endothermic reaction is favorable because the temperature increase means you have more heat. When you have more heat, you need to make it balance again. You need to absorb that heat. The system need to absorb that heat. So endothermic reaction is favorable. So the equilibrium position will shift to the right because temperature is increased. You need to absorb. So endothermic is favorable. Equilibrium position shift to the right to reduce the temperature by absorbing the added heat. When equilibrium shift to the right, you will have more NO2 and you will have less N2O4. N2O4 will be consumed, NO2 gas will produce. Value of Kc and Kp will increase since product increase. When you write down the Kc or Kp expression, Kc equal product concentration over reactant concentration. So here, product will be produced. You will have more product, you will have less reactant. So when you have more product, more number on top of Kc expression, more number on top of Kc expression, less number at the bottom of the Kc expression. That's why the value of Kc and Kp will increase, lowering the temperature of the system. This is the disturbance. This is the equation, and the disturbance is the temperature of the system is decreased. This is the disturbance, temperature of system decrease. So you need to increase that temperature again. If you want to increase that temperature again, you need to give off heat into the system. In order to give off heat, you need to do the exothermic reaction. If you look at this equation, positive delta H means the arrow on top is endo. The forward reaction is endo for positive delta H. So, if you want exothermic to happen, this reaction must be reverse reaction for exothermic to happen. The equilibrium position shift to the left to increase the temperature. Because you want exothermic to happen, because you decrease the temperature. So if you want exothermic to happen, it must increase. You must increase the temperature, so the equilibrium position shift to the left. So when equilibrium position shift to the left, the NO2 concentration will decrease, N2O4 concentration will increase. More N2O4 will be produced, so Kc and Kp value system will decrease. Because Kc, product on top, reactant at the bottom. So you have more reactant, you have more number at the bottom. So that's why Kc will decrease. And Kp will also decrease if you're calculating Kp. Next, for this chemical reaction, delta H is negative. When delta H negative means the arrow on top must be exo. Now, the disturbance is you increase the temperature. When you increase the temperature, endothermic reaction is favorable. Endothermic reaction is absorb the heat. So when the temperature is increased, the equilibrium is achieved by absorbing the heat when the temperature is increased. So endothermic reaction is favorable. If you look at this, endothermic equilibrium position shift to the left for endothermic reaction to happen. So when the position shift to the left, the product concentration will decrease, the reactants concentration will increase. So more N2 and H2 will form, and H3 is decreased. So value of Kp or Kc decrease. Next, the disturbance is lower the temperature. Look at the delta H. Delta H negative means the forward reaction is exo. Our disturbance is temperature decrease. If the temperature decrease, you need more heat to make it balance again. If you need more heat, exothermic reaction is favorable. Exothermic reaction, if you look at this arrow, the equilibrium shift to the right. When equilibrium shift to the right, reactants concentration will decrease, product concentration will increase. More NH3 produced, amount of N2NH2 is reduced. So the value of Kp or Kc increases.